Did you know that one of the largest predators in Earth's history was not a shark, but a whale, with teeth powerful enough to bite into bone? Around 10 million years ago, the oceans were home to two apex predators at the same time, the giant shark Megalodon and a macroraptorial sperm whale, known as Livyatan, Melville. Both hunted large marine animals, including whales, and both occupied the top of the Miocene food chain. Livyatan lived during the late Miocene epoch, approximately 9.9 to 8.9 million years ago. Its fossils were discovered in the Pisco Formation of southern Peru, a region that was once a nutrient-rich coastal sea. The most important find was a skull, nearly 3 meters long, uncovered in 2008. From that skull, paleontologists reconstructed an animal estimated to measure between 13 and 17 meters in length. That made Livyatan comparable in size to many estimates of Megalodon. Unlike modern sperm whales, which mainly eat squid using suction feeding, Livyatan was built to hunt large prey directly. Modern sperm whales have small functional teeth, primarily in the lower jaw, and they rarely use them for combat or tearing flesh. Livyatan was different. It possessed massive enamel-coated teeth in both the upper and lower jaws. Some teeth exceeded 30 centimeters in total length, including the root, making them among the largest teeth of any known predatory animal. The structure of Livyatan's skull reveals how it hunted. Its jaw muscles attached to broad, reinforced regions of the skull, called temporal fossae. These large attachment points indicate a powerful bite force capable of gripping and tearing large animals. The teeth interlocked when the jaws closed, creating a crushing and shearing mechanism, rather than a simple puncture bite. Many fossil teeth also show wear patterns, chips, and scratches consistent with repeated contact with bone. Scientists know this animal was an active predator because of the anatomy preserved in the fossil record. The skull retains evidence of a large spermaceti organ, similar to the structure found in modern sperm whales. In living sperm whales, this oil-filled organ is used to generate powerful echolocation clicks. These clicks can travel long distances underwater and allow whales to detect prey in dark or murky environments. Livyatan likely used echolocation to track large prey in the Miocene Ocean. Sound waves emitted from the head would bounce off nearby animals and return as echoes, giving the whale information about size, distance, and movement. This would have been especially useful in deep or low-visibility water where vision was limited. At the same time, another giant predator dominated the oceans, Otodus megalodon. Megalodon was a massive mackerel shark, estimated to reach lengths of 15 to 20 meters. Unlike whales, sharks rarely fossilize because their skeletons are made of cartilage. Most evidence of Megalodon comes from fossil teeth, some measuring over 18 centimeters tall. The feeding behavior of Megalodon has been reconstructed from bite marks found on fossil whale bones. These marks often appear as deep, serrated cuts caused by the shark's triangular teeth. Scientists believe Megalodon typically attacked from below, targeting the flippers, spine, or tail of large whales to disable them before feeding. Fossils from Peru suggest that Livyatan and Megalodon shared the same ecosystem. The Pisco Formation contains whale skeletons bearing different styles of bite damage. Some bones show the serrated cuts associated with sharks, while others contain deeper, rounded punctures consistent with the conical teeth of Livyatan. In some cases, both types of marks appear on the same skeleton. This evidence suggests that the two predators may have hunted similar prey or scavenged the same carcasses. They likely competed for large baleen whales, which were rapidly diversifying during the Miocene. Nutrient-rich upwelling systems off the coast of South America supported massive populations of marine life, creating an ecosystem capable of supporting multiple apex predators at once. Despite occupying similar ecological roles, the two animals hunted differently. Megalodon relied on stealth, speed, and ambush attacks. Livyatan likely depended more on echolocation, sustained biting force, and active pursuit. A shark could disable prey with a single devastating strike, while Livyatan may have used repeated bites combined with head-shaking motions to tear apart large animals. Scientists have also considered whether Livyatan occasionally preyed on juvenile Megalodon. Young sharks living in coastal nursery areas would have been vulnerable to a large predator capable of detecting movement through echolocation. Likewise, a mature Megalodon may have posed a threat to younger or injured Livyatans. However, there is currently no direct fossil evidence showing one species killing the other. The fossil record, instead, reveals an ecosystem shaped by competition, specialization, and environmental change. During the late Miocene and into the Pliocene, Earth's climate gradually cooled. Ocean circulation patterns shifted, marine ecosystems reorganized, and prey availability changed. Many species of large macroraptorial sperm whales eventually disappeared from the fossil record, including Livyatan. Megalodon survived longer, persisting until roughly 3.6 million years ago, before also going extinct. Scientists believe changes in climate, prey distribution, and marine food chains contributed to its decline. Today, Livyatan remains one of the most important discoveries in marine paleontology because it changed how scientists view ancient whales. Rather than passive filter feeders or deep-sea squid hunters, some prehistoric whales evolved into active macropredators capable of hunting large vertebrates. The story of Livyatan and Megalodon also demonstrates that ancient oceans did not have a single, uncontested ruler. Multiple apex predators evolved different strategies to survive in the same environment. One relied on stealth and serrated teeth. The other relied on echolocation and crushing jaws. And although scientists continue to uncover new fossils in Peru and elsewhere, one question still remains unanswered. If these two giants ever truly fought, which predator would have had the advantage?